All right, today we are diving deep into a real-world security audit of a progressive web app. You know, those apps that run on your browser but feel just like the native ones on your phone? But we're not just going to point out the flaws. Oh no, we are going to translate a dense security report into an actual step-by-step playbook. One you can use to find, to replicate, and most importantly, to fix these exact same issues in your own work.
So you did it. Your new app is out there. The features are amazing, the UI looks fantastic. But there's always that little voice in the back of your head, right? That question every developer, every client asks, is it actually safe? Well, today, we're going to find out.
Look, if you want to build a fortress, you have to think like the person trying to tear it down. So that's exactly what we're going to do. We're going to follow an attacker's playbook piece by piece, using a real security report as our guide. You'll see precisely how they sniff out weaknesses and what those flaws look like in the wild. And then we'll flip the script and show you how to build the patches.
Okay, first things first. Every professional audit, every legitimate hack starts with a mission. And that mission comes right from the client in what's called a client brief. This is the document that lays down the law. It sets the rules of engagement, defines what's in and out of bounds, and what tools you're allowed to use.
Now, the brief will specify the testing approach, and there are basically three flavors. A black box test is where the hacker knows nothing, just like a random attacker on the internet. A white box test is the total opposite. They get the keys to the kingdom, the full source code, to find really deep flaws. For this audit, we're using a gray box approach. It's a hybrid, and it's super common. It means the tester has a regular user account, letting them simulate what a malicious insider or a hijacked account could do. It's often the most efficient way to find the most damaging vulnerabilities. The scope here is crystal clear. We're told to go after the big stuff. User logins, how passwords are being stored, or if they're being stored correctly, and every single place a user can type something, like search bars. We're also checking the server setup. Basically, we're hitting all of an attacker's favorite targets.
All right, mission accepted. Time to put on the black hat. Now let's see exactly how an attacker thinks and how they'd take on this mission to find the cracks in the app's armor. First stop, the front door, the login page. Now, an amateur might try guessing passwords. A pro tries to break the lock itself. And the playbook for that is surprisingly simple. You target the username field, you inject a tiny piece of malicious code, and you try to bypass the password check completely to walk right in. And this is the golden key. This little string of text is a classic, beautiful, and devastatingly effective SQL injection. See, a vulnerable app just mashes this text into its database command. So instead of asking, is the user admin and is the password correct, the app is tricked into asking, is the user admin or is 1 equal to 1? And since 1 always equals 1, the database just goes, well, yep, that's true, and throws the doors wide open. Access granted, no password needed. So at its heart, that's what SQL injection is. It happens when your app blindly trusts what a user types in and mixes that input directly with its own commands. It's pretty much the digital equivalent of letting a total stranger walk up and start giving orders to your security guard. And that's exactly why it's considered so critical.
Now, a good attacker never stops at the first hole they find. Whether they got through the front door or not, they're immediately going to start tapping on the walls, checking the windows, and looking for any other cracks in the foundation. They want every possible way in.
And the next thing the report checks is password storage. Wow, the difference here is night and day. On the left, you've got the worst-case scenario. Passwords stored in plain text. It's just sitting there. If an attacker gets into that database, it's game over. They have everyone's login. On the right, though, that's the secure way. The password is hashed. It's been scrambled into unrecognizable gibberish by a one-way function. Even if the attacker steals this, they can't reverse it. The real passwords and your users are safe. Next up, the attacker moves to the search bar to test for a totally different flaw called cross-site scripting, or XSS. They start by injecting this little piece of code. Now, this script itself is harmless. It's just a probe. Think of it like a canary in a coal mine. If the app is vulnerable, it'll run this code, and a little alert box will pop up on the screen. That pop-up is the signal. It's the proof that a much more dangerous attack is possible.
Yeah, that little alert box is a huge red flag. It proves the critical vulnerability exists because the app isn't cleaning up user input before showing it back to them. And if this simple script can run, a truly malicious one can too. One that could steal a user's session cookie, which means the attacker can just become that user on the site, no password required. Or could redirect them to a fake login page to steal their credentials. The possibilities are terrifying.
Okay, we've done enough damage. Finding problems is only half the job. A great security report is a blueprint for action. So now that we've seen how to break the app, let's look at the exact code changes we need to make to fix these things for good. This right here is the part of the report developers live for.
So here's the fix for that SQL injection we saw earlier. The insecure code on the left is literally just pasting the user's input into the command. That's the big no-no. The secure code on the right uses what's called a parameterized query. It's a simple but powerful idea. It separates the command from the data. You send the command with a placeholder, like a question mark, and then you send the user's input separately as data. The database engine itself handles putting them together safely. The attack is completely neutralized.
And the fix for XSS? Just as direct. On the left, the code is just blindly echoing whatever the user typed right back to the browser. On the right, the code wraps that input in an escape function. All this function does is it takes dangerous characters, like those angle brackets for script tags, and turns them into harmless text equivalents. The browser then just displays the code as text instead of actually running it. Problem solved.
So after all this, the attacks, the fixes, the code, what is the single most important lesson to take away from this entire report? What's the number one thing? It's this. Security is not a feature. It's not something you just bolt on at the end. It isn't a one-time check. It is a continuous process. It's a mindset of constantly probing, fixing, and retesting that has to be woven into every single thing you do.
So there you have it. We've gone from the client's mission brief all the way to the code level fix. You now have the blueprint. You know how to spot and, just as importantly, how to simulate these critical attacks yourself. So the final question is for you. Security isn't just a feature, it's the foundation your app is built on. Now that you know what to look for, what's the first crack you'll check for?